Hello everyone. Here we're starting with the skeletal system, more specifically the axial skeleton. And in this PowerPoint presentation, we're going to talk about the divisions of this axial skeleton. Although you may think of bone as this inert structure, you should now realize that they are quite dynamic structures. Just think about what we learned on the previous module when we talked about the bone tissue and bone tissue formation. Not only that, but the entire skeletal system is intimately associated with other organ systems. Bones are going to be attached to the muscular system, for example, and this will provide movement. Bones are going to be extensively connected to the cardiovascular and the lymphatic systems, and this is important for immune response and blood cell formation. And bones are even largely under the physiological control of the endocrine system. In fact, the bones, they do play an important role in controlling sugar metabolism, energy balance, and some studies even suggest that bones can control weight. Also, the digestive and the excretory systems or urinary systems, they play important roles in providing the calcium and phosphate minerals that are needed for bone growth, which we have already talked about. In return, the skeleton represents this reserve of calcium, phosphate, and other minerals that can compensate for changes in the dietary supply of these ions. The basic features of the human skeleton have been shaped by evolution, but because no two people have exactly the same combination of age, diet, activity pattern, and hormone levels, the bones of each individual are going to be unique. As discussed in the bone tissue chapter, bones are continually remodeled and reshaped, and your skeleton will change throughout your lifetime. Examples are going to include the proportional changes at puberty and also the gradual osteoporosis of aging. And in this chapter, it will provide other examples of the dynamic nature of the human skeleton, such as, for example, the changes in the shape of the vertebral column during the transition from crawling to walking. Now here we can see on this slide that there are actually 206 named bones that will make up the adult skeleton. I know it sounds like a lot, but at the end of this module and next module, you guys will know exactly which bones they are. A lot of these bones are paired, so it's not that you have to know 206 different bones. So it will make it a little bit easier for you to know all the bones. But they will be divided into these two subdivisions, which are the axial and the appendicular skeleton. Bones of the skeletal system, they're going to be grouped into two principal divisions, like I said previously. First, the axial skeleton, then the appendicular skeleton, where appendic means to hang onto. And this is exactly what the appendicular skeleton system does. As we can see from this image, the appendicular is this tan color and the axial is represented in the blue color. Therefore, we can see how the appendicular, which is formed by the upper limb and lower limbs, are hanging from the axial skeleton. And by the way, axial means line. Therefore, the bones of the axial skeleton are going to be lined up along the central core of your body. This image is dividing the bones into the axial division and the appendicular division, where we can see that on the axial division, we're going to have a total of 80 bones, and on the appendicular division, we're going to have a total of 126 bones, and this will give us a total of 206. I don't think that I'm going to go over all the bones on the table right now because basically I'm just going to be reading off of the table, but we will cover these bones in the next few slides for the axial system, and then on the next module we'll cover the appendicular system. However, these tables are good resources if you want to check them in the future.